All right, this is the second problem on the first homework assignment of the week of April 13th, our first foray into series. Been a while since you've seen series probably, and this is kind of a weird one to start with, but it's actually easier series than normal. So I want to just remind you of the process. If we were going to write a series, we would take our function, start taking derivatives, right? First derivative, second derivative, third derivative, so that would be our first step. And then after that, we take those derivatives and we plug in whatever our c is. In this particular problem, it's going to be 2. So you plug in that 2, and you just get a value. And then you take that value and you multiply it by x minus c to the n over n factorial. So we would do that manually most of the time, right, by going through this process of derivatives. However, in this particular problem, I didn't write it here, but they give you a chart that has all the values of the derivative, for function, first derivative, second derivative, third derivative, fourth derivative, and so on. So we don't really have to find the derivatives because we have those values. So the first question is to write the first degree Taylor polynomial. So remember, the first degree Taylor polynomial we stop here means we take that function, plug in the 2, that's our first term. The next term is going to be the first derivative, plug in 2 times x minus 2. So I have those numbers there. Function's 80, first derivative is 128. So the first degree Taylor polynomial is 80 plus 128 times x minus 2. They asked me to use that to evaluate 1.9, so I just plugged in 1.9 for x, and I got 67.2. The next question said, is that approximation too low or too high? You're going to see this problem bounce up a few times this week. We'll probably see it more down the road also. Remember that any of these approximations that we do in class pretty much are using tangent lines. Okay? So if they're asking you if an approximation is too high or too low, basically they're asking, is the graph concave up or concave down? Because if the graph is concave up, that means your tangent line's underneath that curve the whole time. So we're approximating value on the curve is always going to be too low. If my function is concave down, my tangent line is going to be above it. My approximation is always going to be too high. Remember, what we're doing is using a tangent line to approximate a curve. So what I did, I took the second derivative at 2, looked on the chart, second derivative of 2 as 488 over 3. It's a positive number, meaning my graph is concave up. I got to say that in my explanation, which means my approximation is too low because the tangent line is below the curve. Part 2 says, write the third degree Taylor polynomial. I'm going to have to flip the board over for you to see the answer, but same thing. Third degree is take the function, take the first derivative, take the second derivative, take the third derivative, plug in 2 to each one of those things, and then multiply it by the corresponding part. So that's the general term for every problem, right? No, sorry, not for every problem, because it would be a C if it was every problem. But for this one, it's f of 2, f prime of 2 times x minus 2, f double prime of 2 times x minus 2 squared over 2 factorial, and f triple prime of 2 over x minus 2 cubed over 3 factorial. Normally we would have to find those derivatives, but I have the values in the chart, which I'm just going to plug in here. And the values in the chart, 80 plus 128, 488 over 3, and 448 over 3 times the corresponding part. Again, they wanted me to plug in the 1.9. I don't really know why they wanted to do this again. It seems a little bit silly, because it's just arithmetic. Hit the calculator, put in 1.9, start punching the calculator. Got 67.988. Last part says use the Lagrange error bound to show that this approximation was less than 3 times 10 to the negative 4th. So Lagrange error, I mentioned this in the notes. Lagrange error is just the formal term for what we've been doing. Every time we did a problem, so find the error, find the error, find the error. It's just the next term, right? It's just the next term. Lagrange was the guy who figured that out, so it's actually called Lagrange error. So it just means the next term. So they want to know, is this approximation within 0.0003? So I just find the next term, which is the fourth derivative, evaluated at 2 times x minus 2 to the 4th over 4 factorial. The fourth derivative was 584 over 9 from the chart. X minus 2 to the 4th, I plugged in that 1.9 here to get a negative 1 to the 4th over 4 factorial. Just punch the calculator. Got 0.00027. Got to show that that's less than 0.003. So that's your first practice with the series. Pretty good chance there's going to be a series problem on the AP test. Series is the main difference between A, B, and BC, or one of them. So they're almost always on there. Now this year with a cutback, probably even more likely. So we're going to start to practice some series questions. Some of them can be really hard, some of them can be really easy, some of them can be different. Just take some practice. So for this first one, it was a little bit weird, I know, but we didn't have to take any derivatives, which was kind of nice. They just gave us all those numbers.